computer. Okay, now I'm recording. So this is the first question that I'm recording. I'm so sorry about that. I forgot to record the question. Okay, so now please try to read it together. Then I will answer Abiyat question. Okay. AEF, AEF, ABC, BE, DE. Okay. So what is your question, Abiyat?
The force due to ED, AEF, would it be pointing horizontally to the right?
What do you think about it, Abiyat?
I think it would be pointing horizontally to the right. I'm not like sure.
Why?
Because like this shape, because usually if there's two force member that's the shape of an L, they take the direction of the two force member in the hypotenuse of that L.
Okay, so this is a frame problem. Okay, this is a frame problem and frame and machine problem. Okay, for this kind of case, what you're supposed to do is try to analyze first to try to analyze which part is two force member. So if you take a look at the system, ED is actually two force member, right? If it's two force member, then the force is supposed to be pointing from E to D or D to E, right? Then beside ED, EB is two force member as well. So those two, you can treat it as two force member.
Okay.
Yeah.
Okay.
ABC is not two force member. There.
So this one would be like X. So at A, it would be X and Y. AX and AY.
Sorry. Which one? A?
At point A, the force would be AX and AY.
Okay. And yes, it's correct. So if you want to find if you want to draw the member AEF, okay, I think I will stop sharing screen, right? Okay. And I will use the whiteboard. Okay. So just now, the free body diagram will be like this roughly. Okay. At A, just now A is at the bottom, right? So at the bottom there will be AY and EX. Okay. Then there is a force from the two force member. What is the name just now? AD. Or what? The horizontal one.
ED.
ED. Okay. This one is FED. And then there is another two force member from the
EB.
from EB. Okay. EB. Something like that. Then beside that we have two weight from the box. W1, W2. That's the free body diagram. It's supposed to be like that. Okay. So in this case, we have the unknowns that we have is are four unknowns. So we will not be able to solve it directly. Okay. So like it or not, you have to join with the member below just now. Okay. Would you mind to share it again, Abiyat?
Okay.
One, two. Yep. Yeah. You can solve it by solving the member ABC as well. Okay.
Wait, I want to ask, is ED a two force member?
Yes, ED is two force member.
But in the question, it is asked to draw the free body diagram of DE.
Yeah, it's okay. Two force member, you still can draw the free body diagram.
Oh, okay. Oh, never mind.
Yeah, you can still draw the free body diagram. Okay, then. Let me try to explain to you guys why ED is two force member. Okay, let me share the screen then instead. Okay, why ED is two force member? Because if I draw ED, it will be like this, right? Roughly it will be like this. Something like this, right? And then here, we're supposed to have two forces. And then here, we're supposed to have two forces as well. Okay, it's supposed to be EY, EX, and then this one supposed to be DX and DY, something like this. Okay, then if you use sigma Fx equal to 0, what will you get? The only forces there that is in the horizontal direction is only EX and DX, right? It's supposed to be 0. Okay, in this case, our EX will be the same as minus DX. And the same as if you use sigma Fy equal to 0, what you have there will be EY plus DY will be equal to 0. Okay, then what you get will be EY is minus DY. So if later you draw it, okay, if later you have to draw it, everything will be like this. Then if you use sigma moment at one side, okay, if you use sigma moment at E equal to 0, what you will have there will be dy multiplied by the moment arm, L. For example, this one is L maybe. I forgot the length just now, equal to 0. Okay, dy will be 0, right? So later, what you will have in your force will be just Ex is going there, dy is going, dx is going there. So it's two force member, right? Correct or not? Yeah, it's two force member. Okay, now I will continue with the next free body diagram. This one, okay. The next free body diagram, it will be like this, right? Just now. At this part, there will be AX and AY. I draw it this way because here AY is going up, AX is going to the right. This one, AX is going to the left, AY is going down. Then after that, in the middle, roughly, there will be force due to EB. So something like this. And at the end, there is a horizontal force and vertical force as well. Okay, so in total, the number of unknowns that we have is 1, 2, 3, 4, 5, 6. Okay, 6 equation. 6 equation, and in total we have 6 unknowns, and in total we have 6 equation as well. From the first free body diagram, we have 3 equation from sigma Fx, sigma Fy, and sigma moment. From this one, from the second free body diagram, we have 3 equation as well. So you will be able to solve it. Okay, does this answer your question, Abiyat?
Yep.
Okay. Any other question? Oh yeah, just now Zaza, right? ACC, not Zaza. CC.
I've already sent the picture.
Okay, let me download. Open file. Okay, let me share with the others as well. Okay. Can everyone see the picture from CC?
Yes, sir.
Yeah,
okay.
Pak.
Okay. So CC, what is the question?
I want to ask, because there are 2 partitions, right?
Yep.
and that there's a moment in the middle.
Okay, yeah. Well, you mean by partition means the cut, right?
Yeah, the cut.
Cut number 1 and cut number 3. Okay.
Yeah.
Cut number 2. Okay. Yeah. So
like cut number 2 would be right after the moment, right?
okay.
It's
yes.
just after the moment.
Mm-hmm.
So does that mean that like for cut number 1, because moment acts upon the beam equally, like does that mean that for cut number 1 from where point A is to cut number 1, do we include that moment?
Oh no. For cut number 1, yeah, of course you don't have to.
No? Okay.
Yeah.
Before
So,
the cut number
so something like this. CC. Okay then. Let me try 240 Newton per meters. Okay. Okay then. I think I will explain it. Try to explain it using this. Okay. This is too many of the thing. I think I will just erase the other. So you don't have to. This one, whenever you have a cut like that, right? Let me draw it again. So just now the problem is like this, right? This one, and in the middle there is a moment clockwise. Here, 240 Newton meter, right?
Yeah.
Then we have AY, AX, and then we have BY. Okay. My assumption is you already know the value of AX, AY, and BY.
Yeah.
Okay. So the first thing that you're supposed to do is not to solve the cutting, okay, but to solve for AX, AY, and BY using sigma fx, sigma fy, and sigma moment. Okay. After you solve that, then you can after you solve that, then you can do the section. Okay, the cutting. This is number 1, this is number 2, for example, like that. Okay, for cutting number 1, okay, if you want to draw the free body diagram, it will be like this, right? Roughly like this. Then there is AY there. Okay, this is the free body diagram. Right? Then you have to complete it with the shear force, free going down, the positive one, and moment going like that. Correct or not? CZ. Yeah. So this is your cutting, and because the first cut, the equation is supposed to work from this particular point AY until the moment 240 Newton meters, right?
Yeah.
So the cutting happen in between those two, right? If the cutting happen in between those two, the moment you don't have to include the moment, right?
Yeah.
So your free body diagram will be like this. But remember, you have to draw the distance there with x instead of the actual value.
Okay.
Yeah. And for the second section, yes, if you want to use, if the second section is like this, if you want to use the left part instead of the right part, okay, then in that case, you have to draw the 240 Newton meters. You have to draw it like this, right?
Yeah.
You have AY here, and here we have 240 Newton meter. And here, as usual, you have to draw for the positive V and positive moment, like that. And this is your X.
Oh, okay, okay.
Something like this. That's if you use the left cut. But if you use the right cut, the right part of the cut, this one, instead of the left one, okay, you don't have to draw the moment as well.
Oh, okay.
This one. So it's up to you. So for the second cut, there are two options for the second cut. You can use the left part of the cut or the right side of the cut or the left side of the cut. If you use the left side, it will be like this. But if you use the right one, it will be like this.
Okay.
Okay, and we have Py here. Okay, and because the cutting is on the because the force and moment is happening on the left of the cutting, that's why the positive side is supposed to be going where? For shear force.
Shear force would be going up.
Going up, yes, it's correct. Going up. Shear force supposed to be going up. How about the moment? Clockwise or counterclockwise?
Clockwise.
Clockwise, correct. Something like this. And but the most likely your problem your mistake will not be the how to draw the free body diagram, but this one, the distance here. The distance there. What is the distance there now?
4. So it'd be 4 minus x.
The whole length from A to B is what? 4 meters.
4 meters.
Oh, the
So
whole
it
length
would
here
be-
is 4 meters.
Yeah.
Okay, if the whole length is 4 meters, so this one is supposed to be 4 minus x. Yes, it's correct. So you can either use this one for the second cut, or you can use this one for the second cut. It's up to you.
Okay.
Okay?
Yeah.
So it's supposed to be good then. Okay, in that case, anyone else want to ask question? If you want to ask question, you can either share your screen with me and with your friend, or you can do like what CC did, or like what Abia did by sending the file as well. 35 participants. Oh, okay. So in order to force you to come, I think using Zoom is much better. Wilmark, do you have any question, Wilmark?
No, sir.
No. Okay. Who else here? Raffi, where is Raffi?
Hadir, sir. Hadir.
Hadir. Okay. Do you have any question, Raffi?
You can knock next door to find Rafi, sir.
Nah, not next door. It's around 300 or 400 meters from my house, so it's quite far.
Ayo Lofi, kuliah tambahan.
But I believe Raffi told me that you are going, you went to Cimahi, right? Raffi?
Udah balik lagi ke Puri Dago.
Ah, you return back. Okay. Do you have any question, Raffi?
No, sir.
You sure? So you know how the concept behind the cutting and why we have to draw the diagram as well, right? And how to draw the diagram, right?
Inshallah, sir.
Inshallah. Have you watched my video, Raffi?
Of course, I watch all your videos.
Ah, good then. Okay, any other question? There are a lot of difficult questions in the previous year, previous year paper. If you have tried it and you fail to execute it, you can ask me here. Anyone have tried the previous year paper? No?
I haven't looked at it.
Or you haven't looked at it? Okay, then in that case, I will share it to you guys then. This is some of the last year problem example.
Sir.
Can you see it?
Sir.
Yeah. Why?
Can you discuss the one from the midterm examination 2018, number 2, sir?
2018, number 2. This one, right?
Yes.
Yeah. What's wrong with this one?
The external force, sir.
External force.
At E and F. How do you find it?
At B and at
E,
F.
at E and F.
Sorry. I can't hear it. I can't hear it clearly.
At F, sir.
At F and at
E and F.
E. Oh, at E. Okay then. At E and at F. Okay.
Yes, sir.
Okay then. Let me discuss about this. So your main problem is to find out the external forces. So you know that you have to draw the moment and normal and shear force diagram for member B, E, F, G. You know about it, right? But the problem for you that you face right now is to find out the external force, all the external forces, for example, like that, right? Okay.
Yes, sir. Yes, sir.
Bukan siapa-siapa is who are you?
It's Manaf, sir.
Okay. Okay, so I will explain it to everyone as well. So this is the things that we want to discuss now. Okay, try to read because your friend already Manaf already read it by himself. For the others, please try to read it first and try to understand the problem first before I explain it. Okay, so basically the things that we have to do is this. Okay, yeah. And in order to solve for distributions, internal normal shear force distribution and bending moment distribution for member B, E, F, G, the first thing that you're supposed to do is to solve for external forces. Okay, what is the external forces at B? What is the external forces at E? What is the external forces at F? And what is the external forces at G? After you solve that, you will be able to solve for the diagram by doing 3 cuts. The first cut is supposed to be between B and E. The second cut is supposed to be between E and F. And the last cut is supposed to be between F and G. Okay, but you can't do that before you solve for the external forces. Okay. Now, how can we solve for these external forces? Yep. That's the question. Okay, how can we solve for these external forces? At B, there is supposed to be no problem, right? Because it's one rope only. Okay.
Yes.
At G, there is supposed to be no problem as well at G because there is only 100 kilogram mass here.
Yes, sir.
Okay. Then, can you find Manaf, right? Okay. Can you find 2 force member there in this particular system?
DF.
DF is 2 force member. The meaning
EF.
of 2 force member means that the force at F, okay, at the force at F, okay, we can represent the force at F with a force which in the direction of DF, right?
Yes.
So there is one unknowns there. Okay. Then the other unknowns is EX and EY, right?
Yeah.
Okay. EX and EY. There is another unknowns there. Okay. And the other unknowns as well is FAB, right?
Yeah.
Okay. So how many unknowns there, Manaf?
3.
3.
Wait, 4.
FAB, EXEY, FDF, right? So
Yeah,
4 unknowns. Can we solve for that directly? No, what?
Don't think so. Yeah.
Yeah.
No.
So in that case, you have to draw for the free body diagram of CDE as well. Okay. At CDE, there are 2 force at E, EX and EY, 1 force at D, FDF,
Yes.
and 2 force at C, right? CX and CY. Correct or not?
Yes, sir.
So
Yeah.
in total, the number of unknowns that you will get is 6 unknowns. FAB, FDF, EXEY, CXEY.
Yes.
Okay, 6 unknowns. And how many questions that you have, Manaf?
6.
6, because we have 2 free body diagram. The first free body diagram is BEFG member BEFG, right? The second free body diagram is CDE member.
Yeah.
for the external forces.
All right, sir. Thank you, sir.
Okay.
I get it. Yeah.
Okay, for this one is slightly complicated as well, but this one is frame. So I believe you're supposed to know how to solve it. Then this one, this is some of the problem example here. Sorry, this one is last year exam. This one is last year exam. Okay. So this one is for number one, the one that is in question is the normal force and bending moment diagram of member GED. GED, this one. So basically, what you're supposed to do here is to find out all the external forces which is happening there. All the external forces which is happening there. Then after you solve it, then you will be able to solve for the normal force and bending moment diagram. Something like that. Okay, number two is more difficult actually. It's quite difficult. If you want to try a difficult frame problem, you can try for this one. This case is quite difficult. You can try it. Okay. Who else here has already tried to solve for last year problem example? Last year exam paper. And this is your quiz, right? I already posted in the YouTube how to solve this one. This one is frame problem. Okay, I think I will discuss a little bit all the things here, which is directly related to the internal force and internal moment. Okay, let's try to discuss about this problem. This is last year problem as well, 2015. You are asked to draw the moment diagram of member CDE. Okay, CDE, moment diagram of member CDE. Okay, remember at C here, there is a roller, and at A here, there is a pin. So basically, the first thing that you're supposed to find out is this one, CX here, DX dy here, and EX EY here. If you already found out those values, you will be able to draw for the internal force and internal moment diagram. That's the thing.
Sir,
Okay.
I have a question.
Yep, Victoria, yes.
So about this question,
This one.
we do only for the CDE, right?
Yep.
So forces from bar A B is moved to the D point. So
yes, correct.
Oh, okay. So we cut it between CD and between DE.
CD and D. No, there will be three cuts, Victoria. CD, there will be one cut between CD. Then after D, there will be another cut for the horizontal part, okay? Then this part, there will be another cut here. So there will be another cut here. So first cut will be here.
Okay.
Can you see my mouse?
Yes.
Yeah, this one is one cut. This is second cut. This is third cut.
Oh, okay, sir. Thank you.
Yeah. I think for this one, I will try to post the solution via YouTube as well, because this kind of cut, I believe most of you have never tried before. When there is a vertical member that you have to draw the internal force and internal moment as well.
Sir, is it the same as the last homework? Because for the last homework, we got one question that's a man bar.
Wait. Last homework.
Uh,
Let me check.
question 1, I think.
Statics.
It was a welded bar.
No. I mean, okay. This is, yeah, it's quite close, but it's slightly different because at this particular one, you mean this one, right?
Yes, sir.
Yeah. But for this one, the one that is in question is the normal shear and moment diagrams only for this part only, the horizontal one only. The vertical is not in question. You understand what I mean?
But the question said for the beam loaded by the force F. Doesn't that mean that
No,
that's
but
the vertical?
no, the vertical is not, because this one F is applied to the strut welded to the beam. So in this case, this part is the strut, this part is the beam. So the vertical one is actually is not in question. You understand what I mean?
Oh, okay.
So this one is strut, this one is beam. Oh, so in the problem, in this particular problem, you try to find out the distribution and the strut as well then, for your case. Or not? Victoria?
Okay, sir.
No, I mean, when you try to solve this in the previous homework, okay, did you try for this one as well or not?
Yes, I thought that the diagram asked was for the vertical bar, so I only draw for the vertical bar. I draw for all of them. Yeah, I draw for all of them.
Okay, but if you already did that, means you will be able to solve for the exam problem as well. But for this one, actually, the one in question is only this. You don't have to find this one as well. Okay.
Okay, sir.
Okay, I want to ask you. I want to ask the others then, beside Victoria. If the question here, if the question for the homework number 1 is to find out the normal, shear, and moment diagrams for all of the part here, including the strut. Anyone here having problem with that? In this case, we have to have 3 cuts. The first cut is supposed to be here. The second cut is supposed to be here. And the third cut is supposed to be here. Okay? There will be 3 cuts there. If any of you still having problem with this, I will try to solve for the exam problem.
Wait.
Yep. Abiat?
Wait. When you said 3 cuts, is that to find the internal force systems within the strut?
Yes, as well. If I mean, now I'm asking all of you, do you have any problem to find out the internal force of the strut as well?
Were we supposed to find the internal force of the strut?
For this particular homework, not. Nah. But if I ask you if I ask you now, right? If you are asked to find out the internal force and moment for the strut, can you do that or not?
Would we have to find the the force in between the weld, like, you know how it's welded, right? Would we have to find like the X force, Y force, and moment there at that point, or no?
You can do it that way, or you can draw the whole free body diagram as well, or actually you can use this particular cut as well.
Okay.
You understand what I mean, right? So
yeah,
when we cut it at number 3, we can use the top part, this one, or we can use the bottom one. For the bottom one, if you don't know what is happening at the welding, at the welded part, okay, you have to draw the whole things, including this one.
Okay.
So it is easier to cut from the top.
Yeah. Wait, sir, I have another question.
Yep.
for this. When you, because for this homework question, it was only to find the thing, the internal force systems for the beam, right? The horizontal. But like when you cut at second section between B and the right end, if you took the right part of your cut, would you also have to find the moment welded part, or could you?
Nope. You don't have to. What you can do is like this. The drawing, you can draw it just this way. Okay,
okay.
Something like this. And you draw the strut as well with the others. So so the F here. Then what you have here is the shear force going up positive
Upward.
V, then normal going there, and this. You can solve it that way as well. And this one, and because X is from the left, right? So this one is supposed to be, this distance is supposed to be, B is 5 meters, so 10 meters minus X, something like that. That's all. And H here supposed to be, what is H? 3 meters. You can solve it that way as well.
Okay.
For the others, about the strut here, if I ask you to find out the internal force, internal moment at the strut, if you still have problem, I think I will post another video about it. Anyone here still have problem with that?
Oh yes, sir. Is it okay if you post problem example for like a bent bar or like a welded bar?
Okay, in that case, I think I will post another video about this one. Okay, wait. Okay, if I think I will post another video about this then. The last year exam. This one. It's supposed to be okay, right?
Yes, sir.
Okay then.
Yes, sir.
Yeah. Later I will post another video about it. So but most likely it will take quite a while. So by tonight I will be able to post it, I believe. Okay. Any other question?
Can I ask about this question? Just
which
like,
one?
This one, though.
Oh, this one.
Yeah.
Okay. Yeah.
What, like, you know how there's internal force systems for the horizontal part, but what about this bent part? Like, would we have to?
Oh, the bend part. No, you don't have to. You don't have to analyze for the bend part. So, what you have to do is to analyze for the horizontal only and the vertical only.
Okay.
The bend part is actually is out of the topic.
Okay.
Yeah, it's quite difficult to solve that one, and you don't have the tools to solve that.
Okay. And another question: if we were to solve for the vertical part, would we use like, because you know how when we solve for the horizontal beams, we X meters, but if it's vertical, would we use Y meters? And would that be
it's okay. It's supposed to be okay. So for this one, okay, let me capture this snipping tools. I think it is much easier to explain all of this with the wait. Wait a minute, okay. Okay, can you see this now? Yeah.
Yes.
The problem with this one, right? Actually, later after this I will post it, right? But I need to explain it before I post it. So most likely later what you will have is like this. The free body diagram will be like this. And at C there will be Cx because it's a roller here. Okay, remember this one is a roller, okay? At C, it's Cx. Yeah. Okay, this one is Cx. Then at D, there will be Cx and Cy. Sorry, dx dy. Then at E, there will be, it's supposed to be Ex, Ey as well. Okay, now if we cut like this, right? This is the first cut, okay? Later, what you will have will be just like this. Okay, for the first cut, what you will have will be just like this. Cx. So you have to still draw everything like this, right? And phi, okay? But later, what you will have there is only the n is supposed to be equal to Cx, something like that, okay? But remember this this direction, okay? This is the direction there, okay? Now the second cut, for the second cut, the free body diagram will be like this. Okay, there will be Cx and around here there will be dy and dx. Same, we have to solve for n, phi and m there. And the positive direction is like this. Okay, remember that. Now, the last one, this particular cut, third cut. Okay, if we want to draw for this one, this part, then my free body diagram will be like this. Okay, this one will be Cx, and then dy, dx. Then this is the most important part, okay? The phi is supposed to be going down, right, normally on the right side. But now the phi is like this. The normal force is supposed to be going outwards, right? Still going outwards. And the moment is supposed to be like this. Do you understand what I mean?
Sir, if it's like that, then the distance x is from Cx to the bent part?
No, this one, actually in one graph, right, you have to create in one graph, right? So this one is x, this one is x as well. This plus this is x.
Also, the x is following the bar?
Yep. So okay. Just now, right, for the first cut, the x is like this. The second cut, the x is like this. Okay. The third cut, the x is supposed to be like this until the third cut. Okay. Because later, why we have to do it that way? Okay, why we have to do it that way? Because later when we draw for phi, n, and m, okay, the x-axis is only one, right? So we have to continue with that. So for example, this is the location of C. This is the location of D. This is the location of the band. Then this is the location of E, like that. You understand what I mean?
Yeah.
Yeah. So something like that. Yep.
So in total it would be 0.8 for the
yep, correct.
third.
In total, in total here, from here to here is supposed to be 0.8 meter for the graph, for the diagram. So we draw from CD, okay, this is the first cut, and after that D to the bend, it will be the second cut. This one is 0.0 to 0.2. So the first cut, okay, the first cut is for X from 0 to 0.2. The second cut is for X from 0.2 to X equal to 0.6. Then the third cut is for X from 0.6 until X equal to 0.8. I divide this as my X as well. Okay, that's the way to draw it. That's the easier way to draw it. Okay. So,
okay.
but the most important thing is here, how to define the positive, V, N, and M when the alignment changes a bit like that.
Sir, but why would the moment be anti-clockwise?
Yeah, still the same with this one, right?
But that's like the left cut. Wouldn't you consider this the right cut?
Huh? The right side of the cut, yes, anti-clockwise, right? Remember, right? If
no,
we
yeah, but I meant like I thought that you were drawing the right side of the cut across.
no. This one is the right side of the cut. This one is the right side of the cut as well, right? This one is the right side of the cut, right? So whenever we have something like this, then we cut it here. If we analyze the left part, right, this one, the moment positive is supposed to be like this, right? Correct or not, Ibian? If we analyze the left part, the right part, this one, this part, okay, the moment positive is supposed to be like this, clockwise.
No, I meant like I didn't mean as in right side of the cut, as in the right side of the part that you're analyzing. I meant like like what's it called?
What?
If you were to, you're looking at it vertically, right?
Yeah.
Do you like turn the object? Like, do you rotate the object so that it becomes as if it's horizontal, so that you can, like, can you explain it clearly in that way?
Yeah. Yes, correct. Actually, for this one, right? Actually, what I did is just the same as turning this particular part, the vertical part, into horizontal actually. So this one, I turn it like this into horizontal actually. So everything will be the same as this one when it is horizontal. Correct or not?
Oh, okay.
Yeah.
But like, does it, if you rotated it not, like, you know how you rotated it clockwise? What if you rotated it anti-clockwise? It would be different. It would be like the left cut instead of the right cut.
For me, right, whenever I analyze about that, right, the easiest way is actually to determine from the moment, Abiat. Okay, moment positive is always trying to make the beam smiling, right? So actually, if this one is my X and this one is my X, the beam will be smiling, right? Because of the moment, like that.
Yep.
Okay, so what you're supposed to do is to define your positive X direction. If your positive X direction is like this, then continue it like that. Your moment is supposed to be like what I drew just now.
Okay.
Yeah, so the first thing that you're supposed to do is to determine which is the positive direction of the X. Like that.
All right.
Okay. Any other question about this? After this, I will try to post the solution for this one, because this one is quite difficult as well. And at E, it will be quite troublesome actually at E, because there is a 300 Newton there as well. And there is a force from the BE beam as well, which has to be transferred at point E. Any other question?
Not yet, sir.
No? Okay. I think in that case, it's supposed to be enough for today. But remember to watch, keep watching my video over and over again if you want to keep practicing, okay? And beside that, the other things that you're supposed to do is to try to practice with the previous year exam paper, okay? Those problems there are quite difficult to solve, so try to practice with that. Okay, try to practice with that. Okay.
Yes,
If there is no more question about it, I think that's all for today's class. I will post this video as well, this question and answer session to the YouTube. And beside that, I think by tonight I will try to finish the video for the solution of the exam paper that we talked about just now. Okay. In that case, that's all. And don't forget to mark your attendance, okay? For today's online class. Okay.
Okay, sir.
Thank you,
Okay,
sir.
sir.
Thank you, sir.
Terima kasih, Pak.
Yup, yup.
Terima kasih, Pak.